Good morning. So today what I'm going to do is try to quickly show you how to use your OneBot chassis and outfit it with DC motors. Okay, and I'm going to show you the most basic form of control. There's not going to be any pulse width in this particular video. It's just going to be on, off, left, right, forward, back, stop. Okay, we'll get into finer control in a video here shortly, but this is the basics. So first off, if you want to use DC motors, the simple DC motors, you need to get, a couple of DC motors, which I have, okay, would come with a nice wheel, and you need to get a modified motor mount, okay, only one of these, because these motors that I have here only have two mounting holes, so it's going to attach itself. Something like this, and then below the chassis you can see it here, that would be this beam here, and there are two screws here, and then through screws attaching the motor to the underside of the chassis. The OneBot's already pre-drilled to accommodate this extremely common H-bridge driver board that I also have on the site, as well as lots and lots of different modifications and placements for the motherboard. In this case, I don't have to do it this way. I've decided to mount it so it's off to the side, and we've got a nice layout. The batteries ultimately will sit right here, but for this tutorial I'm actually going to run it all off the USB. And so let's even talk about that for a moment. Okay, what are my settings on the OneBot? I have this jumper here set to the 5 volts, okay, and I also have this jumper on this side of the board set to 5 volts and not VN. Reason is I don't have batteries here. Okay, I'm going to do all my testing with the robot off the ground, sitting on little jacks, so there won't be any load on the wheels. I just want to test my code, and I'm going to run all power, including that of the motors, off the USB in a free rolling state. So it actually does have enough power to do it, and works rather well. So let's talk about the layout here. Actually, let's talk about the goal first. I have a link here that talks about the L298 chip. This is the chip. Oh, you can't see it now. Let me go back to my video. This chip on this board is an L298. It's a dual H bridge. It can drive 2 DC motors with reasonable current and or 1 stepper motor. And what we want to do is we want to look at this logic table and understand that if I have 1/2 of this chip dedicated to 1 motor, okay, what I need to do is, if I want the motor to rotate one direction or the other, I need to set one of the control pins high and the other low. If I set both control pins to low, it puts the motor on an active brake. If I set both the control pins to high, it sets it on an active brake. There is another enable pin, which I'll show you in a second. Currently I have mine defaulted to high, okay, and so there is no capacity to do a coast, okay, and let me show you that on this board again. Let's jump back to my video. It's a little difficult to see here. Maybe I'll zoom in on this particular piece. Okay, if you look at the board, there are in fact 2 small jumpers, one right here and one right here on this side. Okay, these 2 jumpers are the enable pins, and they are jumpered to high. Okay, they're on. As long as this thing is powered up, it is on. So I'm only using these 4 wires. 2 of them control this motor, 2 of them control this motor, okay? And if we follow those wires, we see that they make their way over to the motherboard here, and I have them hooked into pins 3, 4, 5, and 6. 3 and 4 are controlling one motor, 5 and 6 are controlling another. Okay, so let's zoom back out so we can see the whole thing. And now let's look at a piece of code. This is actually remarkably simple if we're going to do just basic control without PWM. So there's really no speed control. It's either on or off, forward or back. First thing we have to do is create some variables to hold our pins. Okay, so it takes 4 pins to control 2 motors. Okay, I've named mine in pin 1, 2, 3, and 4, and I've set them up with the teensy pins 3, 4, 5, and 6. Okay, and now if we go down to this hunk of code, I set all of these up as outputs. I also threw in the, just to make sure, because I want to use this light as an indicator here, I've set my onboard LED to output as well. Let's look at a teeny piece of code going forward. Okay, if we go back to this logic table, if I want the motor to spin one way or the other, direction 1 or direction 2, I don't know yet if it's forward or back. It depends on how it's wired. I have to have one of them set high and one of them set low. Okay, and that's going to change the direction, or it's going to set the direction the motor moves. Let's go back to this and this. Okay, so pin 1 and 2 are controlling one motor, and you can see I have one of those set to high and one of them set to low. All right, down here 3 and 4 I have also set low and high. Okay, now I had to test this. All right, it turns out because I've wired my motors this way with the red wire in front and the black wire in back, and because I happen to have soldered it onto my motor in such a way, by testing it out, I now know that this combination of low high makes my robot go forward. Okay, it makes one wheel spin clockwise and one wheel spin counterclockwise. Remember, they're on opposite sides, so essentially the robot goes forward. Turning left means that I have to switch the direction of one of the motors. Okay, so you'll see that I have a high low and a high low. All right, turning reverse, I completely flip them. High low, low high. Stop for, oh, I should go back to the explaining this actual piece of code. Let's go that forward. Low high, high low. Okay, turning right, low high, low high. So I've flipped this. The only other thing I've done in here, because I'm actually running this thing off the USB, which is a low current supply, if I turn on all these motors at one time, it ends up actually stalling out. It's just too much to go from a dead stop to motion with all 4 motors that are all 2 motors, all 4 pins being set at the exact same time. It just doesn't have enough current to kick it in. So what I do is I give this first motor a 5 millisecond head start. Okay, I get it moving, I break it free of its inertia, and then I kick on the second motor. Okay, and then it's going to run, it's going to stay in this state for a period of time, and that period of time is going to be showing up in this argument. So if we look down here, we see these are all the same way. I give the first motor a teeny 5 millisecond head start, get over the inertial resistance, reverse, same exact thing, stop. Okay, just like that data table showed you, if I go low low or high high, it's going to put it in an active brake. Okay, this particular one is only going to stop for a period of time. What the robot is in right now is what I call final stop, whereas I do bring the robot to a complete stop, but then I create an infinite loop where it's simply going to flash the LED on and off, and it cannot escape from that until the processor is reset. So that's a final stop. If we look at the code, we see we've got it here. Forward 500, so it's going to go, the wheels are going to spin in a forward direction for half a second. It's going to stop very briefly. Okay, it's going to go into a turn right for half a second. It's going to stop, and then turn left for half a second, stop, goes into reverse for half a second, and then it goes into final stop, and you can see that it gets stuck in this infinite. Now I'm going to pause it briefly because I have learned that it takes a long time the first time I load it up on this computer, and I'll have it preloaded so it goes quick. Hold on. Okay, so I've preloaded it, so now you can actually watch it. It's going to go pretty quick. And we're going to do a compile and load. We'll watch the blue bar zip across. And it does this short run. Okay? And let me just prove to you it's working. Let's throw it into forward for 5 seconds, and we'll throw it in reverse for 5 seconds. And of course now I've changed the code, so a little bit longer to upload, but not bad. Okay, those are forward for 5 seconds, and the reverse for 5 seconds. Okay, that's it. Now what's really nice about these DC motors is they're a lot faster than the servo motors, especially when I hook it up to a higher voltage supply as well as just a greater source of current by the nice battery pack here. I'll post the code, and I will see you again shortly when we talk about PWM, or pulse width control, so we can change the speed of the motors. See you soon.